Hey guys, these notes are for solving quadratics using the quadratic formula. Our essential question is, what is the quadratic formula and when can we use it? So we have learned 4 methods so far. So we've learned solving by graphing, solving by factoring, solving by using square roots, solving by completing the square, and then this is the final and 5th way, which is solving quadratics using the quadratic formula. Now, for the last 4 methods that we have learned, to solve them, what were we solving for each time? Well, every single time we were solving for x, or whatever the variable was. But that represents our x-intercepts. We are looking for our x-intercepts. Okay? And then the standard form of a quadratic equation, again, is ax squared plus bx plus c equals 0. Okay? And it's an equation, so there is an equal sign. All right. So with factoring, not every quadratic is factorable. Sometimes we get a not factorable quadratic, so I couldn't use factoring for every single quadratic equation I see. For using square roots, I can't solve by using square roots for every single problem because I need my b to be 0, and not every quadratic has b equaling 0. For completing the square, it works best when a is 1 and when my b is even. If a isn't 1, then I probably shouldn't be using completing the square because it doesn't work out as nicely. And then finally, we are here at the quadratic formula. Now, you can pretty much graph almost any parabola and you'll get x-intercepts, but it won't give you an accurate reading, right? It'll give you some decimal answer. A quadratic formula can be used for literally any quadratic equation, any single one. So on your STAR test, if you have just completely blank and you can't remember how to solve anything using any other method, use a quadratic formula. Okay, quadratic formula will be on your STAR formula chart, so you do not have to memorize that. All right, so the quadratic formula, now if you want to watch and look at it first before you write it down, it is x equals, and remember it's x equals because we're solving for the x-intercepts. X equals negative b plus or minus the square root of b squared minus 4ac, all over 2a. The entire thing is divided by 2a. Now, it looks really scary, but I promise it's not honestly that bad. You'll realize later on that your calculator is a lot of what you need it to do anyways. Okay? Now, make sure you have that formula copied down correctly. You don't want to have the wrong formula down and do all of your homework problems incorrectly. Also, if you're watching this video, you should be taking notes, okay? Because you can't absorb anything if you're not actually doing something. So the part under the radical, okay. So let's talk about the part under the radical. Now remember, a radical is just an umbrella term for all of our types of roots. So this is a square root. So a radical is the square root here, and it's talking about what's under the radical. So this part right here, what's under the radical, that b squared minus 4ac, is called the discriminant. Okay? And this determines how many solutions we're going to have. So if my discriminant, my b squared minus 4ac, is greater than 0, if it's bigger than 0, so it's positive, a positive number, I have 2 solutions. That means it's going to cross my x-axis 2 times. Okay? The second one, if my discriminant, my b squared minus 4ac, is equal to 0, I'm going to have 1 solution, which means it crosses my x-axis 1 time. Oh, 1 solution, there you go. Lastly, if b squared minus 4c is less than 0, and what kind of numbers are less than 0? Negative numbers. If it is a negative, if my discriminant, which is the number under the square root, can I square root a negative number? No. That gives me no solution. Okay? I can't square root a negative number, so there's no real solutions, but when you get to Algebra 2, you are able to square root negative numbers because they'll teach you how. All right, so our steps for using quadratic formula, there's technically 4, but there's 3 important ones, okay? The first thing you need to do when you're solving a quadratic equation using the formula is you need to set one side equal to 0. And it does not matter which side. So if you want to make your x squared negative, by all means do whatever you want to do. But I just need one side equal to 0. It doesn't really matter what side. But for graphing and factoring, I need it to equal to 0, but my a term needs to be positive. Here it doesn't really matter. Next, we're going to identify our a, b, and c. Okay? If we look back at the quadratic formula and I ask you, all of this right here, what variables are being used? A, b, and c. So you do need to identify your a, b, and c so you know what to put in or to plug in, and that's what part 3 is. You're going to substitute a, b, and c in parentheses, okay, in parentheses. I'm going to highlight that. I put it in caps for you. You're going to put it in parentheses in the formula. So anytime you plug in, you will use parentheses. You do not want to mess this up because one little small mistake is going to give you some wrong answer. You don't want that to happen to you. All right. Number 1. Let's begin. First step is to make it equal to 0. So it doesn't really matter what side, but the easiest thing for me to do would be to subtract that x over. Okay. 3x squared minus 1 minus x equals 0. Now, I prefer this to be in standard form, so it's a lot easier for me to find my a, b, and c. So I'm going to move some things around. I'm going to move the negative x first, and then the negative 1 behind it. Okay? Now, after we have set it equal to 0, and after I put it in standard form, what I want to figure out what my a, b, and c are. So my a here is going to be positive 3. My b is negative 1. Remember, a, b, and c are numbers. They are just numbers. There's no x. And then my c is going to be negative 1. Now my b and c here are both negative 1, and that's just by coincidence. There's not like a magic trick to this. So your b and c could be different. Your a and b could be different. They can all be different. I'm going to copy the formula down right here. Oops. Just so that we have it for reference while I am plugging it in so you know what I am doing. Okay. Let's use purple actually. All right, so remember it's x equals because we're solving for x-intercepts. Now, when you're plugging in, all you're plugging in is the a, b, and c. You leave everything else the same. So I still have that giant division bar, okay? In the very beginning for that negative b, I still have the negative sign. But now I'm going to plug in my b value, and my b value is negative 1. And remember, we identified it over here. And then I have plus or minus the square root, okay? Now I need to plug in a b again. My b is negative 1. So I have negative 1 squared, and then I have minus 4, and then I have to plug in again. I have to plug in my a, which is 3, and then I have to plug in my c, which is negative 1. Do you see how every time I'm plugging something in, I have parentheses, okay? You want to use parentheses. You might not like it, but it will help you prevent a lot of mistakes. And that division bar, that giant division bar, that fraction bar, is going to go across the entire thing. So it's not over just half of it, the whole thing. And then you have 2 times a, which is 3. Okay, now this looks super scary. I promise it's not that bad. So we still have our x equals, and we're going to start simplifying this. So we have my division bar here. Now, negative here, negative 1 is just a positive 1. And then I still have the plus or minus, okay? And I also have that square root there. So I'm going to leave all of those as is. And then next I'm going to look at the 2 times 3, which is going to be 6. Okay. Now, my next step here, I need to simplify what's under the radical. So I'm going to highlight all of this in green, everything that's under the radical. And you can actually just punch that right into your calculator or into Desmos. So you can put in parentheses, negative 1, parentheses squared, minus 4 times 3 times negative 1. So that sign in front of the 4 is a minus sign, not a negative. So you do want to make sure you plug in everything correctly. And then so here, in calc, I'm so sorry I can't show you because I don't have my calculator on me, but you're going to type in negative 1 squared minus 4 times 3 times negative 1, okay? You don't type the square root in. You should get 13, okay? And then at this point, before you box your answer and be like, I'm done, like, that's it, you always want to check to see if your radicals can be simplified any further. So I have square root of 13. Well, I know 13 is prime, so I actually can't simplify that any further. And then the last thing you check for is you check to see if you can simplify your little fractions here. So I have a 1 here, a 6 here, and then technically in front of this radical, I do have a 1. So I want to look at all 3 of these numbers. Is there a number I could divide out of all 3 and it would work? No. So that means that this is my simplest form, so this is my answer. Now, when you're looking to divide a number out of all 3, you're not looking at the radical. You're going to treat it like an x, and I'll show you an example of that later on. So you can also write it as 1 plus square root of 13 over 6, and x equals 1 minus square root of 13 over 6, because you do have 2 solutions. You have that plus or minus. See how the plus and minus is already built in the formula? You don't even have to think about it. All right, so those could also be our answers. I give you a lot of room. I'm sorry about that. All right, number 2. Okay, here I need one side to equal to 0. That's my first step. Some people might want to move the 1 and the negative 2x over to the left. But personally, I'm going to move the 2x squared to the right. Again, it does not matter for the quadratic formula. It will accept it either way. Okay? So I have 0 equals 1 minus 2x minus 2x squared. And I do want to write this in standard, so I'm going to move the negative 2x squared to the front, and I move the negative 2x and then the plus 1 there. Okay, so make sure you bring those signs with it. All right, my a here is negative 2, b is negative 2, and c is 1. Okay, and then my next step is I have to plug it into the formula, so let me write this formula down again. Okay, so now I'm going to plug in, let's use purple. All right, I have negative, and then I'm going to plug in my b, so negative 2 plus or minus the square root, negative 2 squared. Remember, you plug in with parentheses, you do not want to forget that, and you plug it into your calculator exactly the way you see it. Don't try to skip the parentheses because you might get something wrong. And then my a is negative 2. All right, so I plugged in my a, b, and c everywhere that I've seen the variables, so you should have something that looks like this, and I'm going to simplify. Okay, well, I know that negative 2 is going to give me a positive 2, and then I have plus or minus, and then the square root. And then in the denominator, in the bottom, I have negative 4, because 2 times negative 2 is negative 4. Once I simplify this radical, I believe you get 12. Yeah, you get 12. So you should get 12 once you plug in that stuff under the radical in the calculator. You don't plug the radical in the calculator, just what's underneath the radical, the discriminant. Again, before you box your answers, you always check, is my radical simplified? So you're going to check to see if square root of 12 can be simplified. You get 4 and 3, 2 and 2, okay? So I have one pair and one lonely child. So remember, we're going to take one car and we're going to have the 3 on the inside. So when I rewrite this, everything is exactly the same as always. All I did was simplify square root of 12, and now I have 2 square root of 3. Okay? And then lastly, before you wrap everything up, you're going to look at your 3 main numbers here. The numbers are not in the radical. The first number, the second number attached to the radical, and then the denominator. And you're going to see, can I divide something out of all 3 of these? Okay? And the answer is yes, I can divide out a 2 from all of them. So I'm going to divide a 2 out. And so 2 divided by 2 is 1. And then I have plus or minus. 2 divided by 2 is also 1. But I'm not going to write that 1. It's just kind of unnecessary. And then lastly, you have negative 4 divided by 2, which is negative 2. So this is your solution, or your solutions, might I say, because you have x equals 1 plus square root of 3 and over negative 2, and you have x equals 1 minus square root of 3 over negative 2. And you're like, well, why didn't I divide the 3 by 2? Okay, so it's kind of basically, if it was, you treat it like an x. So if you have 2 plus or minus 2x over 4, then you would do it the same way. You don't mess with that x. You just look at all 3 of your numbers. You just look at these, and you divide them all by 2. Right? So you technically have the same thing. So you treat your radical like an x value. Okay? Now, just to be hypothetical about this, let's think about this for a second. Let's say I had a 3 here, and I had these 3 numbers. I had 2, 3, and negative 4. Is there anything that goes into all 3? No. So then you stop, and that is your final answer. You just box that entire stuff in blue. Now, since I had a 2 there, and I can take out a 2 from all things, and I do, you always want to simplify at the very end. That's like our technical 4th step. After you plug in, you need to simplify. All right, number 3. Okay, so this one's kind of tricky because it didn't give it to you in standard form. So you don't want it to trick you and make you think that the 48 is the a value, right? So I'm going to go ahead and rewrite this in standard form. Okay, so my a value here is negative 1, b is 48, and c is 100. All right, so I got some big numbers here. I will go ahead and write down the quadratic formula again. All right, so I have x equals negative 48 in parentheses plus or minus the square root of 48 squared minus 4 times negative 1 times 100. Now, I'm just reading everything I'm writing, so it might sound like a bunch of stuff's going on, but I'm just plugging in A, B, and C. Okay, so you should have x equals negative 48 plus or minus the square root, and then you have negative 2 at the bottom. And then you're going to simplify all that, and I believe it's 2,704, but I need to double check real quick. Oops. Yeah, so it's 2,704. Okay, so I simplified all that was under that square root. And you're like, whoa, okay, I don't know how to simplify this radical. Well, you should always check to see if it's a perfect square. So always type in square root of whatever you have to see if it's a perfect square before you try to simplify. So if you type in square root of 2,704, you actually get out 52, because the square root of that is 52. So you have x equals negative 48 plus or minus 52 over negative 2. Now, you've square rooted 2,704 already, so you should just get a 52. No more radical. Your square root is now gone. Okay? And your last step is to see if you can combine your like terms. So, can I combine 48 and 52 normally? Yeah, I can. So this is where you need to write it separately before you start simplifying anything. So you have x equals negative 48 plus or minus 52. And then you have x, and over negative 2, my bad. Oh, wait. What am I doing? Okay, this is plus. I'm going to do the plus for that one. And then I have negative 48 minus 52 over negative 2. All right, so you're splitting them up. You're taking your plus and minus and writing them as two separate solutions. On the left over here, you should get negative 2. And on the right over here, you should get positive 50. So your solutions would be that your quadratic intercepts the axis at 50, 0 and negative 2, 0. So it has two solutions here. Okay, moving on to the next one. Now, quadratic formula, like I said at the very beginning, it works for every single quadratic. But is it always the quickest or the fastest? Definitely not, okay? Number 4 is actually so easily done with taking the square root, and I will show you like right now. And then we can do the quadratic formula, and I'll show you we get the exact same thing. So again, it's just, we show you all these methods so that you can choose the method that works best. But of course, if it asks you to solve it by quadratic formula, you have to. All right, so if I'm going to take the square root really quick, so I'm going to add 18 to both sides. Now, this is not using quadratic formula. I'm just showing you how easy it is to do it with a different method rather than quadratic formula. All right, you square root both sides. You get x equals plus or minus the square root of 18. Now, if I simplify square root of 18, I get 9 and 2, 3 and 3. So I have one pair and a child. So I have 3 square root of 2. So really, my answer is plus or minus 3 square root of 2. That's my answer. That was pretty quick. The quadratic formula won't be that quick, but we will get the same answer. I promise you that. All right, so let me show you in a second. So I'm going to keep that answer there just to show you we get the same exact thing using a different method. But for quadratic formula, I need to have it equal to 0, and I like it in standard. But the thing about this one is I don't have a b value, which is why you can take the square root very easily. But if there is no b value, then your b value is what? 0. So our a here is going to be 1, b is 0, and c is negative 18. So let me go ahead and write down that quadratic formula again. All right, so I have x equals negative 0 plus or minus square root of 0 squared minus 4 times 1 times negative 18 all over 2 times 1. Now, if you think you got it, go ahead and try it on your own, and then you can kind of skip through to see if you did it correctly. Because I know, like, I'm doing this kind of quickly, so I'm assuming that maybe you've tried it already. Or if you want to pause and just watch. Or you pause and try it on your own, that's fine too. Okay. So negative 0 is actually just 0. So I don't even need to write it, because that's like saying like x plus 0, which is just x. So the 0 is gone. I'm not going to write it. And then I have the square root here, and then I have a 2 in the bottom, the denominator. Now, if I simplify my radical, I should get, not simplify the radical, simplify my discriminant, I should get 72. Now, again, you always check to see if 72 can be simplified, your radical here. So I have 8 and 9, 4 and 2, 2 and 2. So I have a pair here, and then I have 3 and 3. And so I have another pair here, one child. So my radical is 3 times 2 square root of 2, which is 6 square root of 2. So that means I have x equals plus or minus 6 square root of 2. I've simplified that, all divided by 2. Okay? And then you ask yourself, lastly, can I divide out all my numbers by the same thing? Now you're like, well, what's the number in the front? Technically 0, right? So if you really want to write the 0 there, sure, it's just kind of weird, but you can. So you can look at all three of your numbers. Can a number divide out all three of them? Yeah, I could take out a 2 from all of them. And you're like, you can divide out a 2 from 0? Yeah, you can. You can take 0 divided by 2 and you'll get 0. So that's why 0 doesn't really matter. So really, you're just looking at 6 and 2 here. And 6 divided by 2 is 3. So you have x equals plus or minus 3 square root of 2. See, we got the same thing from what we did earlier. But again, different methods, but this one will always work for any problem. That's the nice thing. Okay. Number 5. First step, want it to equal 0. So I'm going to subtract 49 on both sides. So I have 0 equals negative m squared minus 14m minus 49. This is already in standard form, so it's kind of nice. I know we're going through a lot of problems, but it is important for you to watch all of them because, again, they've all been very different. So some of them have been missing a b. This one missed a b. This one you actually can simplify and get 2 nice numbers at the end. This one you have to simplify your radical. And then the first one you didn't have to simplify anything. So all of these examples are very different, and that's why there's 6 of them that we go through. All right, so let's identify our a, b, and c. A is negative 1, b is negative 14, and c is negative 49. Okay, let me write that formula again. Oh, and we're talking about m here, so I'm actually going to put m equals instead of x equals. Negative b plus or minus the square root, b squared minus 4ac all over 2a. Now I have m equals negative 14 plus or minus the square root of negative 14 in parentheses squared minus 4 times negative 1 times negative 49 over 2 times negative 1. Okay. So I have a positive 14 plus or minus the square root. In the denominator, I have negative 2. Now, if I simplify what's in my parentheses right now, I'm going to get, I think, give me one second. I get 0, right? I get 0 if I simplify all that in my calculator. Now, what's the square root of 0? 0. So that kind of just goes away. Now, remember at the very beginning of our notes, we said if the discriminant is 0, how many solutions are we going to get? Let's look. If my discriminant is 0, I'm going to have 1 solution. So, let's see if that's true. I just have 14 divided by negative 2 here, which simplifies to m equals negative 7. So I only have 1 solution here. I have no plus or minus, so nothing. Not nothing. 1 solution. So I only have 1 here. Lastly, number 6, and I promise this is the last one. Again, you want everything to equal, one side to equal 0, so I am going to move the 3r squared over, just because it's the easiest thing to do. If you want to move the 3r and the negative 2 over, that is perfectly fine too. And then going to move it into standard form, just so that I don't mistakenly mark something as A, B, or C when it's actually not. Red. Okay. A equals negative 3, B equals 3, C equals negative 2. So quadratic formula looks kind of scary at first, but is honestly, you're doing the same thing on every problem, and it is the same process for all of them. You check the same thing for all of them. Let me write this formula down again. All right, and then I'm going to start plugging stuff in. Okay. Now, once I get here, I have r equals negative 3 plus or minus the square root, and then I have negative 6 in the denominator. Now, if I simplify what's under the radical, my discriminant, I'm going to end up getting negative 15, okay? Now, I've square root of a negative number. Can I actually do that? No. If my discriminant is a negative number, remember we have no solution. All right. But that is it for this video. If you're in pre-AP, I will go ahead and derive the quadratic formula in a separate video just so that this one's not too long. But